Hello everyone, we are from tutorial 8 group 2 and our chosen element is methyl red.
This is all our group members.
Introduction part. First of all, methyl red is an azodide that made up of benzoic acid with a 4-dimethylamminophenyl diazenyl group that substituted at position 2. Methyl red, also known as CI-acetate 2, is a monocarboxylic acid and a tertiary amino compound that belongs to the azobenzene family. In addition, methyl red are well known as common use for modified chemical in a laboratory and utilized in ingredients as pesticide.
The objective part, firstly to determine the synthesis pathway of methyl red from the simplest hydrocarbon, and secondly to determine the reactions that methyl red can go through and the effect of methyl red to the human body.
Synthesis pathway of methyl red. For the preparation, as an azodide, methyl red be prepared by diazotization of n-ternilic acid followed by dimethyl aniline. Firstly, synthesis starts with orthoaminobenzoic acid and the first diazole produced by sodium nitrate and acid hydrochloric. Then, diazole coupling reaction with an n-dimethyl aniline to produce the final product, which is methyl red.
There are 5 reactions of methyl red. The first reaction is the reduction of methyl red to a primary alcohol. This reaction involves the reaction of methyl red with a strong reducing agent such as lithium aluminum hydride to produce a primary alcohol. The carbon atom of carboxyl group is in a relatively high oxidative state. So, reduction to a primary alcohol takes place rapidly on treatment with a powerful methyl hydride reagent. The second reaction will be the nucleophilic acid substitution reaction. For this reaction, the electrophilic character of the carbonyl carbon plays an important part in the reactivity of carboxylic acid. Carboxylic acid derivatives tend to undergo a reaction called nucleophilic acid substitution. The third reaction will be the acid chloride reaction. In this reaction, the carboxylic acid group will react with the thionyl chloride, which is SOCl2, to form acid chlorides. However, it can also react with PCl3 and PCl5. They are the most reactive carboxylic acid derivatives. The carboxylic acid's hydroxyl group is converted to a chlorosulfide intermediate during the reaction, making it a stronger leaving group. During the reaction,
Deprotonation, which is the formation of salt. In an acid-base reaction, deprotonation is the removal or transfer of a proton from a bronzed lauryl acid. Carboxylic acids are a type of molecule defined by the presence of a single carboxylic group. Bronzed lauryl acids are carboxylic acids that function as proton donors. The last reaction is amide. Since amines are very basic, they tend to convert carboxylic acids to their extremely unreactive carboxylate ions, making direct conversion of a carboxylic acid to an amide difficult.
Methyl red can be toxic to human respiratory systems. This can cause respiratory difficulties and irritation of the respiratory tract and mucous membranes is possible. Furthermore, it has the potential to irritate or stain human tissues. Once the human skin exposed to this chemical or an extended period of time, it may cause skin cancer. Skin sensitivity is possible to occur. Methyl red can be harmful to the skin, causing redness and slight discomfort. It also can irritate the human eyes. Last but not least, if this compound is mistakenly indigested, it can cause dizziness, nausea, and vomiting. Disturbances in the gastrointestinal tract can be happen. Long-term or prolonged exposure can cause damage to the liver.
For the conclusion, methyl red is a type of carboxylic acid, also known as CI-acetate 2, is an azobenzene-related monocarboxylic acid and a tertiary amino compound. The methyl red production process begins with aminobenzoic acid. Methyl red can be harmful to human respiratory systems, cause irritation, or stain on human skin,
can give dizziness, nausea, and also vomiting if accidentally swallowed. Hence, methyl red should be managed carefully to prevent negative consequences.
That's all from us. Thank you and stay safe, everyone.